Well, good day. I want to talk to you today about estimation. And estimation means just what the word means in conversational English. I want to estimate something. Suppose that I want to know about the average hat size for men in the USA. Maybe I'm going to take up manufacturing hats as a second job. So it would be very helpful if I knew the average hat size. Now that would be a parameter, so we'll write a Greek letter, mu, and that's what I want to estimate. So this is the average hat size. How would you estimate that? Well, I don't think you'd need any special course in statistics to figure out that you would take a sample of, say, n equal, now this could be anything, but I'm going to say n equal 50 men, and that would be a random sample. And on that sample, you'd calculate x bar. And then you would tell me, well, I think x bar and mu are about the same size. And so I'm going to use x bar as my estimate. X bar is, and we would call that a point estimate. Now, why a point estimate? Well, because it's a single point. What are the advantages? It didn't take long. I mean, you got to go out and collect 50 men at random, and then it's easy to calculate once you've got the hat size for those 50 men. So it's a quick thing to do. It's an intuitive thing to do. The only problem is, while we don't think that x bar and mu are exactly the same, that's why we've written approximately right here, there's no way to know how far off that approximation is. We don't have any error bounds. And so what would be better would be to come up with a confidence interval estimate of mu. Let's see. That looks okay. A confidence interval estimate of mu. And in fact, even more than that, I want to know how much confidence I can have in it. So this is going to be a 1 minus alpha confidence interval estimate of mu. So what are the components here? Well, it's an interval, and I mean just an interval, like an interval on the real number line. So let's just say that the straight line is my real number line, and the left-hand endpoint, let's just call it L for right now, and the right-hand endpoint, we'll just call that R for right now. So this is an interval, and I think mu lives here. I think mu is in this interval. And how strongly do I feel about it? Well, 1 minus alpha will be the probability that mu will be between L and R. So this would be my confidence. Now, I can state that another way. What I want to do is to find L and R so that the probability that L is less than, and I can say less than or equal to, is less than or equal to mu, is less than or equal to R, so that that probability is 1 minus alpha. And without going through all the details of what comes next, this confidence interval is going to be your point estimate x bar plus and minus a value that we symbolize E, where E is the maximum error of the estimate, or sometimes called the margin of error. And it will be pretty easy to find that confidence interval once we define and figure out how to calculate E. And I will tell you right now that E is equal to T alpha by 2 S over the square root of N. And that is a good segue into the next video. S will be the sample. Remember, we've taken a sample. S will be the sample standard deviation, so we know how to calculate that given a sample. N is the sample size, so we know how to take the square root of the sample size. And I'm going to have to talk about the t distribution in the next video. So that will do for now, and thank you very much.